All right, doctor, let's begin with the first question. I'm going to read the question. Sometimes I saw overlapped images in the scan body scan data when I scan multiple scan bodies. Are there any tips to avoid them?
So yes, of course, for avoiding this situation, you should just follow one of the protocols that I presented today. Of course, if this still happens, it is very important that this scan should not leave for the technician in, as it shows. And what are you going to do? First thing, you stop scanning, you hit the optimize button. Then after optimize, you reevaluate the situation of the scan bodies. If you still have errors on them or overlapping data, you are going to delete this data, but just that one. You hit the optimize button one more time and then block everything, because every other information you already have is good and you want to keep that. And you just do an overscan of the missing data that you just deleted. But normally, if you follow the 3 protocols I gave you in the distal scans, scan bodies should not be overlapping. Let's just see how this plays out for you.
All right, the next question. What is the difference between a normal scan and an HD scan?
So talking about normal scans and HD scans, as you might know, the lineup from the Medit scanners, the i600, 700 and 700 wireless, are all having the new engine, and the new engine allows for in vitro scanning of around 10 microns of precision, plus minus 1 micron. But the difference, so the precision in normal scanning and HD scanning is actually the same. The difference is actually the number of points that you are getting. The number of points is around, from my knowledge, you can confirm this, is around 3 times higher. So the mesh is much denser, and the cloud point count is much denser. What's going to help? So you're going to get actually more detailed scan, not a more precise scan, but a more detailed scan. As you can see in these pictures, on the left we have an ST scan, and you can see the margin line is actually touching the next tooth. What happened here is that because the software didn't have enough points to build a correct mesh, it just had the 2 meshes touching. But if you scan this area when you have sharp angles, when you have scan bodies, if you scan this in HD, as you can see on your right, then the details will allow for these margins to present themselves. My advice to you is, as you can see this in the next picture as well. And my advice to you would be, when you have inlays, onlays, scan bodies, or very well shown margin lines of crowns, always go with HD. You don't need everything imaged in HD, but these sharp surfaces, sharp turn surfaces, my recommendation would be to be scanned in HD mode. So let's go to the next question.
Yeah, next question. Question number 3, how do you scan the long span of an edentulous area? In the area with teeth, the scanner works well. However, when I try to scan the long span of an edentulous area, it does not move forward. Literally, it stuck in the middle of scanning. How can I overcome this?
So let's start by explaining what the scanner needs from you. In the live view window on the bottom, you see a tooth and some parts of the fixed gingiva. To move forward, the scanner needs to know approximately 50% of the window. So 50% of the window should already be known data. If the scanner doesn't see known data anymore, it's going to interrupt, and you have to go back to an area that was already precise and well known to the software. The idea is, when you scan teeth, they have a lot of detail. So having a lot of detail, the scanner always knows where it is. When you go to an edentulous arch, the only known surface for it could be the fixed gingiva. The moving parts are going to either be excluded by the software, or if you allow the slider to go to the left and scan everything, they are going to move, always move, and the scanner will lose point. So if you want to scan an edentulous part, my protocol goes like this. In settings, on the live view settings, as you can see on the screen, I'm using a custom window, a rectangle, a long rectangle. I position, and also you are going to use the scan depth at around, let's say, 14, 16 millimeters. When you have these settings dialed in, you are going to start scanning, place your scan tip on the teeth that the scanner already knows, and you are going to place the rectangle in such a manner that it's going to follow the edentulous arch with the fixed gingiva. So it's going to aim the fixed gingiva in the length of it. Now you are going to start from the teeth, go to the end of the crest by doing a slight angulation from vestibular to palatal. And in this way, you're going to have a very fast scan of the fixed tissues, and also getting them in a green reliability mode, because the cloud points are validated by your slight movement of the tip. And now you are going to have from one pass the whole edentulous arch in a green reliability mode. One more thing would be to activate, when you go to this part, Medit introduced a new function. It's called sleep checker. I don't use sleep checker for scanning teeth because it tends to break up scanning a little more. But when you go to the edentulous part, it's going to be great to have good data. So this is the third thing that you have to activate. Just turn sleep checker on. Then do your custom range to a rectangle, as you can see there, and the depth of field 14 to 16 millimeters. Okay, so let's go to the next question.
All right, doctor, but before going to the next question, I have a personal question.
Of course, please.
Yeah, my personal question. So when scanning a long span of edentulous area, some doctor recommend to make or create a marking point using flow over resin. So I wanted to ask you, do you recommend this this method?
Yes, of course. It's the third way I teach in this webinar to scanning scan bodies, and in this direction, what I should say is that I always tend to not use composite resin, because composite resin is very prone to be moved by the tissues, and I use resin modified glass ionomer cements because they are hydrophilic. The important thing when you place the resin, I have to mention, this glass ionomer that I use has to stay only on the fixed gingiva. So you're going to extrude it from the syringe, place markers on the edentulous span, and the assistant is going to come with the light, with the curing light, exactly after you, and she's going to cure these patterns in the following seconds. So you place them, and in 1 second they are already cured. Also, my recommendation to you is, if you have the slightest thought that these patterns of resin have moved from one stage to the next, it is better to remove them and redo the scan, because if they are moved, they are going to introduce imprecisions in the ulterior scanning. If not, this is the technique. What you do this in this scanning in the pre-op stage, and when you finish the pre-op stage, you copy this data to the op stage. You remove the resin cements or the flowable cements that you've placed. You delete them from your scan. You block everything, because now you have a precise information on the pre-op that is copied to the op, and now you just complete the data of the op rescanning.
See, thank you for answering.
My pleasure.
All right, let's go to the next question. Hello, please help. Every day I scan implants for more than 1 year with Medit 700. In the upper jaw, everything is without a problem. The lower jaw is a big issue when the implants are situated in a position to the bridge. When a distal implant doesn't have a tooth beyond, unable to scan distal scan body every time the scanner loses.
Yes, so the solution for this question is already in the webinar. The 3 ways I'm presenting there should help a lot. I want to mention that these 3 ways I presented in today's webinar are just workarounds to the situation that are very cheap to implement and very easy to implement. In the next webinars, I'm going to also show for full arches, but this applies for distal portions as well. I'm going to show scan bodies from the industry that are easily placeable and that they don't need any workarounds and they will get precise data. You will see them as well. And you can use also those solutions. But the idea is, if you use my techniques or if you use those scan bodies, you should not have any problems anymore with distal scan bodies. Let's go to the next question, Sue.
Yeah. Is there a way in Medit Link to import CBCT and intra-oral scan data to do the tentative guided implant and prosthesis planning? A tutorial or staff's guide would be highly appreciated.
Yes, of course, we can do this already. We can build a surgical guide. We have protocols on Medit Link. The idea to build a surgical guide plays as follows. You need the CBCT data, and the CBCT data in planning software are directly accepted. Because we don't have the ability to import DICOM data in Medit Link already, we are going to do a workaround, and this means we are going to segment the CBCT data. To be able to segment CBCT data, you can start from using software like Invesalius. Invesalius is going to let you choose what you segment. It's a little bit trickier to use, and it's going to take a lot of time to segment maxilla or a mandible, but the results are very good if you take the time. Then we are going to go to talk about other software like DiagnoCat, Relu, or Blue Sky Dio. From these 3, DiagnoCat is my favorite. These all 3 are using AI software to segment the CBCT automatically. So normally you're going to only press a button and get the jaws segmented. And then you are having the STL files of these jaws. You can import them in Medit Link, and then with the protocols that Medit provided on the YouTube channel on Medit Academy, it's going to be pretty easy to design a guide. After this being said, I have to be very sincere with you and to mention that right now you have to take great care when doing this, not to intersect with anatomical structures, because there are no tunnels to get these safeguards like for example, in exoplan. So if you intersect anatomical data, you have to be really attentive not to do that and to place the implants correctly. But otherwise, the software works great and the workarounds work great, and you are going to get your surgical guide in 10 or 15 minutes.
Right. Thank you. And next question. Can you give me the workflow for the all-on-4 implant case? Patient presents with 4 implants and a screw retained denture, and he's satisfied with his bleeding and his speech. A patient wants a screw retained denture with a titanium bar.
Yes, so the question is going to actually be addressed in the following webinars, but just as a quick intro to that, you have to imagine that if you have all the data already dialed in, so you have the BD correctly recorded, you have the preoperative scan of the denture or of a bridge, so everything is there. You just have to add a maxilla or a mandible with scan bodies on top that you are going to get on position with the Medit design application. Just try using the 3 ways I already showed and extrapolate them to the full arch. I'm going to show in more detail how I do this in the following webinars, but you can already try these 3 ways to get results until then.
All right, guys, we're going to cover more things about the content and more details in the next webinar, so please don't miss it. And next question. Someone told me if I use AI matching feature, I can save time and avoid some troubles when I'm capturing the scan body. Can you teach me how to use it?
So for me, this question actually is composed of two things. First one, let's address the AI feature. AI feature is a little different than best fit matching that you can find in other software. It's much more advanced and it gives better precision. The best use of the AI function in the Medit software is going to be by importing scan bodies that Medit already has validated. So you have a library of scan bodies, and if you use those libraries, then you're going to get the best results possible. If not, you can also import scan bodies from outside the Medit library, and they are going to work great as well. If they are not already imported, just please let the Medit team have your scan bodies, and in the future they will probably integrate them there as well. And now, without further ado, let's just see how to do this scanning in the AI function. As you can see on the screen, I already scanned the arch, and I already have the scan bodies on the field. So this is the normal scan. Right now, on the bottom left, I'm in the scan body stage, and then I select the second icon to use to place the AI matching. And when this opens, you have a bar with the teeth number. You are going to tell the software what tooth the scan body is onto. And just 1 second, sorry. And I'm clicking on 1.6. And right now I'm going to designate a scan body for it. So we are going to open the list. One is already assigned, so I'm just going to delete it and assign it once more. I have a recent tab. So this is the scan body. I tell the software that 1.6 is the tooth, and I assign the scan body to the 1.6. And now the scan body is on field because the scan is already done. I'm just going to match the scan body with the scanned image by 1-point click. You can see here, very easy. It just cut in, and this is everything. And now the software will have the exact AI matching at the end of processing. Okay, so let's
go to the next question.
To the next question.
Right. Really struggling to scan this edentulous ridge today. Took a long time just to get the bottom arch to actually keep lock. Ended up adding a bulb of composite scan spray and a lot of patience. However, once I took off the healing abutment, I was unable to scan the soft tissue emergence as it just wouldn't scan inside the implant soft tissue space. Any tips?
Yes, of course. As you can already seen in my first protocol, when we place cement, and what we talked to Sue already, when we place cement on top of the ridge, if you scan the arch and then remove the healing abutments on the upstage and block everything, if the cement is still in place, then it's almost touching the healing abutment, but without actually touching it, you are going to have a very easy time scanning the emergency profile. Do remember that if you are on the mandible where tissues are moving a lot, have your assistant detect the cheek and also the tongue, and you should only go with the scan depth to around 14, maybe even 12. And if the scanner sees the blob of composite and also the emergency profile, it's going to be very easy to implement the scan.